For question 8, we're going to talk about neural adaptations during resistance training. So we're going to talk about 3 different adaptations that can happen. The first one we'll talk about motor unit recruitment. This is the process of activating more motor units to increase the strength of muscular contraction during exercise. If more motor units can be recruited, this increases the number of muscle fibers being used, therefore increases force production. So the size of these units are also important. So a smaller unit will be used first, and these are normally found in type 1 muscle fibers. Medium motor units will be used second, and this is usually found in type 2A muscle fibers, and then the larger motor units will be used last in type 2X fibers. So I have a little diagram here of percent of max force and then percent of recruitment of motor unit. So as you can see, at lower intensities, we'll just be using that type 1 fiber, and then as intensity increases, we'll use the type 2A, type 2X, and then it'll just build going off of that intensity and max force that you want to create. And then as resistance training continues, the number of motor units will not be changed, but the number of motor units recruited will increase. So next is the motor firing rate. This is the rate at which motor neurons are sending signals during voluntary muscle contraction, and this firing rate is dependent on the muscle that's being used. So in type 1 muscle fibers, they have slower contracting muscles, meaning they have a lower max firing rate compared to type 2X fibers that have a faster contracting muscle, therefore will have a higher max firing rate. So the average firing rate is 30 to 50 pulses per second, and then as resistance occurs and intensity increases, this rate will increase to 100 to 200 pulses per second, and then this increase in the firing rate allows for higher intensities and speed to occur during exercise. The last one is motor unit synchronization. This is the simultaneous or near simultaneous firing of motor neurons to the muscle fiber. So untrained people will have lower motor unit synchronization, meaning not all of the muscle fibers will be being fired with the motor neuron signal at the same time, but trained people will have more synchronized motor neuron firing. This allows for motor neurons to stimulate each muscle fiber in the motor unit at the same time, and then this produces more force when performing resistance training. So I have a little diagram here. So as you can see, the untrained people, this is the motor neuron. It's not firing. It's not all firing, and then all the muscle fibers are not reaching the signal, but eventually they do, and then trained people, just right away, all the signals are firing and all the muscle fibers are being used, which creates for more force production.